The following presentation is about graphing the tangent function. So we're going to start with the parent function for tangent. So f of x is equal to tangent of x. And if we remember from last time, the identity for tangent is sine of x over cosine of x. When we create this graph, x is the angle measured in theta that is in the units of radians. So we're going to make a table of values and then create a graph from this table. So I was very strategic about the spacing of the x values and the choice of the x values for the tangent function because I wanted to find units that were easy to graph. So we're going to start with tangent of negative pi over 2. So sine of negative pi over 2. And as we go around the unit circle, the coordinates for this point is 0, negative 1. So the sine is negative 1. The cosine is 0. And the tangent is going to be sine divided by cosine. Since we're dividing by 0, the tangent at negative pi over 2 is undefined. For negative pi over 4, we're over here on the unit circle, and that's going to be negative radical 2 over 2 for sine and radical 2 over 2 for cosine. When we divide these two ratios, we end up with a tangent is equal to negative 1. For 0, sine of 0 is 0, cosine of 0 is 1, so the tangent of 0 is 0. Pi over 4, over here on the unit circle, is radical 2 over 2 for both sine and cosine. Sine divided by cosine of pi over 4 is going to be equal to 1. Pi over 2, the top of the unit circle, is going to be positive 1 divided by 0, undefined. And as I keep going around the unit circle, we're going to get enough points to make a complete graph. So the tangent of 3 pi over 4 is radical 2 over 2 divided by negative radical 2 over 2, so negative 1. For pi, we have the sine is 0, the cosine is negative 1 for a value that's 0. 5 pi over 4 and 3 pi over 2 are the last two pieces that we need. 5 pi over 4, negative radical 2 over 2 for both the sine and the cosine. We're in the third quadrant. Both those values are negative, but when you divide them, we end up with positive 1. And lastly, we have sine over cosine of radical 3 over 2, so we're back to where we started. Sorry, sine over cosine of 3 pi over 2. And we are undefined again. For all of these undefined values, undefined means we have a domain restriction. In asymptotes are used to represent domain restrictions on graphs. So we have enough information to create a graph. So I'm going to go with the x-axis. My vertical axis, I'm going to offset it just a little bit. And we're going to start at negative pi over 2. And then the units on my x-axis are going to be pi over 4. that's my scale. And 3 pi over 2. I have vertical asymptotes at pi over 2, negative pi over 2, and 3 pi over 2. So vertical asymptotes. See, -1 and +1. 0, and then the sine and cosine functions, the pattern repeats itself. And the way that we're going to draw this tangent graph is we're going to get closer and closer to our asymptotes without crossing them. It's a curve, not a line. And there's arrows on both the ends of the graph. So this is 2 cycles of a tangent graph. So the cycle is what's happening in between the asymptotes. So here's our cycle. And for this graph in particular, just tangent of x, before we start changing the a's and b values, this cycle is going to be equal to positive pi minus negative pi over 2 is equal to pi, and that is the period. So we just graphed 2 cycles of the tangent function. The biggest difference between sine and cosine is it only takes tangent up to pi to repeat itself. The next thing we're going to do is we're going to translate the tangent function. By translating the tangent function, we're going to change some parameters. So we have y equals a tangent b of x, where a changes the steepness, so the higher the value, the steeper the curve. It will reflect when the a value is less than 0, so when a is negative, which means we'll have an increasing function, so it's going to be pointing up, when a is greater than 0, and a decreasing function when a is less than 0. When we change the b value, what it's going to change, it's going to change the period and the locations of the asymptotes. On our parent graph, we had 3 asymptotes at negative pi over 2, pi over 2, and negative 3 pi over 2. And that's where our cosine values were equal to 0. So as we change the b value, what that means is whatever's on the inside of the function, the tangent function, whenever that's equal to negative pi over 2, and 3 pi over 2, we're going to end up with asymptotes. So when I solve for x in each of these situations, this should be a plus sign. We have negative pi over 2b is our first asymptote, pi over 2b is our second asymptote, and 3 pi over 2b is our third asymptote. Our x-axis is going to look the same almost every single time. What's going to change is what we count by. So our first asymptote is at negative pi over 2b. This next unit here is going to be halfway between negative pi over 2b and 0, and that's going to be negative pi over 4b. Our scale every single time is going to be pi over 4b. 2 pi over 4b. 3 pi over 4b. Instead of writing 4 pi over 4b, that's just going to be pi over b. 5 pi over 4b. 6 pi over 4b is the same thing as 3 pi over 2b. I'm going to reduce this one that I have left unreduced, and that's going to be pi over 2b.